Hello there, this is Professor Roldan. Welcome back to another review. This is Chapter 2, Sections 5 through 8 in College Algebra. And this assignment has been posted to your My Labs Plus or My Math Lab. It is 35 questions, and it is just a way to refresh your memory. And in this session, I'm not going to teach necessarily, just going to quickly review and go through the thought process of each problem. So let's get started. So once again, this is a review. 35 questions, and it covers Chapter 2, Sections 5, 6, 7, and 8. Okay? Now, before we get into transformations in 2.5, let's just quickly look at our parent functions or common functions. We got the constant function, okay, which is a horizontal line, f of x equals c. We have an identity function, or these two are both linear. This is variable, okay. This one has a slope. It could be positive, negative, whatnot. And then both of them have their pretty much the domain or range. Even one is odd. Then you have the absolute value function, okay, which all the negative values that were down here for our identity function turn positive. Okay, so that affects the range. Quadratic, okay, which is an even function, symmetrical to the y-axis. Okay, we have the square root function, which is only in quadrant 1. If you put a negative in front of that, it reflects down into the over the x-axis. If you put a negative inside the radical, it reflects over the y-axis. Okay, our cubic function looks like an S or a snake. Same thing with the cube root. Okay, don't really use this one too much in this chapter, or at least in our presentation of this. Okay, so make sure you know these and you know how to recognize them. Next, we have our shifts, our transformations. We have shifts, we have reflections, and we have vertical, horizontal, stretching, and shrinking. Okay, so this is a lot of information. So let's just quickly run through this. Vertical shifts, if it's positive C, it goes up so many units. If it's negative C, it goes down. If it's positive C inside the parentheses or the grouping symbol, which could be radical signs, it could be absolute value signs, it could be a rational function down here, okay, different areas, okay, and of course parentheses with powers, some type of power. All right, so this, if it's inside the parentheses and it's positive, we're going to go the opposite direction of what we normally would think. Okay, and then negative will go to the right. Okay, reflection about the x-axis. This is true if you do not move the center, okay, or the vertex. If you don't do any horizontal, or if you don't do any vertical shifting, then this is true, reflected around the x-axis. If you happen to move this okay, then you just reflect it down. Okay, so if you happen to move the function before you reflect it, then don't reflect it around the x-axis, but do it just in the downward position. Okay. And then the reflection about the y-axis, again, same thing applies. You want to reflect it to the left. About the y-axis, okay, where the y-axis is the mirror. Okay, so reflection, just a mirror effect. And if you happen to shift to the left or to the right before you reflect it, you just need to move it in the opposite direction. Okay, so then we have vertical stretching and shrinking, and horizontal stretching and shrinking. Oops. All right, so vertical stretching, if the number is greater than 1, for example, 2x squared, if it's 1/2 x squared, then it's a vertical shrink. Okay, it looks wider. So remember, this is narrow or narrower, and then this is wider. Okay. And in this case, let me fix that. So if the numbers are inside, that's a horizontal stretch or shrink. The first one's a shrink, and the other one's a stretch. Okay? So let's take a look at these over here. Actually, let me summarize that real quick. All this big old chart, you can be summarized with the following formula. So y equals positive or negative a f of positive or negative b x positive or negative c and positive or negative d right here. Okay, so this whole chart can be summarized with this formula. All right. Here you have the vertical shifts, up or down. Here you have the horizontal shifts, up, left or right. Here we have a horizontal stretch or shrink. Here we have reflection over the y-axis. If it's negative. Here we have our vertical stretch or shrink, and then here we have our x-axis reflection or reflecting it down or up depending on where you are. Okay, so that's what all this big old chart is saying. It is all summarized. This is the actual positions. Okay, now let's take a look at some of these examples. So I highly recommend that you watch this video and do your practice tests or your review, so that you are very familiar with what's going on, and you can pause it and work on the problem and whatnot. So let's get started. Okay, this is going to go kind of fast since this is just a review. All right, so number one, we see that this is on the outside of the function of the grouping symbol. So this is a vertical shift, and it's negative, so it's down. And we know that our parent function for this guy, it looks like that. Okay, so we take a look, and we need to see something going down, and it's this one right here. So the parent function is the solid in this case, and the movement is your transformation, or the dashed is your transformation. Okay, then we go to number two. All right, same thing applies. This time it's inside the parentheses, so this is a horizontal shift, and it's going to go to the left. All right, and we know our parent function looks like this. So we take a look, which one goes to the left, 2 units, and it's this one right here. Number three, we have two transformations. We have a reflection right there over the x-axis. So it's going to go upside down, or it's going to go in the downward position, and then it's going to go down 4. So they're all pretty much reflected except for this one. That's not reflected. And then the only one that's shifted down 4 only would be this one here. Okay, let's take a look at number 4. Again, we have two transformations. So we know this looks like this from the parent function. We know that it's going to get reflected to the left, all right, because that is a horizontal, that is a y-axis reflection. Okay, so it should be pointing to the left this time, which they all are. And then we need the one that has a horizontal shift to the left 5 units. Okay, so the only one that does that would be this one. So why did it go to the right? Well, first it got shifted to the left 5 units, and then this thing got reflected, so this part is now going that way, and this part is going that way. Okay, a little tricky there. Number 5. The only thing we see here is since this is on the outside, there's no parentheses. This is a, and it's greater than 1, so this is a vertical stretch. Okay, which means the values are pretty much going to be pulled away from the x-axis, and it's going to look narrow. So that would be D. All right, again, we have that vertical stretch, okay, which makes it look narrower. And then we have this horizontal shift to the left. Okay, so horizontal shift to the left, looking narrower, would be A. Okay, you can see the values being pulled away from the x-axis because we're stretching it upward, and it looks narrower. All right. Okay, let's take a look at number 7. Number 7, has some type of stretching or shrinking, but this time it's inside, so that would be a horizontal stretch. Okay, and so horizontal stretch, and this right here is a horizontal shift to the right. Okay, so if you look, we have this one goes to the right 5, and there's a horizontal stretch of 1/2. All right, number 8, we have a vertical shift and a horizontal shift to the right. And they're both by 4. So to the right and down would be A. To the right and down. Number 9, we have, first of all, is reflected over the x-axis. Then we have it's going to the right and going down too. Okay, so it's definitely going to be upside down, to the right 4, and down 2 would be this one. Okay, so this one we can, we know it's going to be reflected over the x-axis right there. So it should be upside down, which means these two are out of the question. And then we know it's going to go to the right 7 and down 3. And the only one available for that would be this one. And as you can see, there is a horizontal, it looks wider. That's because this is a fraction right here. Okay. Number 11. Use transformations of the graph to determine. So this one you're actually going to graph yourself, okay? Just like on the test. All right, so we know the parent function basically is one of these guys. And so we're going to shift that. First of all, we're going to reflect it over the x-axis, so it's going to go upside down. And then we're going to go to the right too. So our new vertex is right here. So we just need to draw, just do a quick sketch. It doesn't have to be perfect. And that's it. So let's continue with number 12 here. And we know it's not going to get reflected, but it's going to shift to the left 2, down 2, which would be right here. And then this, since it's greater than 1, that's a vertical stretch, which is going to make it look narrow or narrower than the parent function. So the parent function is pretty much like this. So we just need to make it narrower. That's all. Okay. All right, so let's take a look at number 13. We have various things once again. So we're going to reflect it over the x-axis. We're going to stretch it or make it look narrower. We have to go to the right and go down. Okay, so we know this is going to be upside down parabola. It's going to be narrower. So we're going to go over 3, down 4, which is right there. Okay, it's going to be upside down and make it narrower. And that's fine. Okay. 14. By graphing the absolute value function, then use transformations of this graph to graph the given function. So all this is a vertical shift downward. So we just look for that vertical shift, which is, or translation right here. And right here. Okay. Number 15. So this is a reflection. This is a shift to the left. I'm sorry, to the right, and this one's down. So we got to mark all three. Reflection about the x-axis. Well, let me just check them off. Vertical translation and horizontal translation. Okay. So this thing should be upside down, which means it's not any of those. And if we go to the right 2 and over 1, it's going to be this one. Okay. Number 16. Okay, reflection about the x-axis, horizontal shift, and vertical shift. Okay, so we're going to go to the left 5, down, and up 3. And it should be upside down, which they all are, so that's not going to help us. The 3, though, does out here means this is narrower, vertical stretch, and they all seem to be narrower, so we just need to find the right vertex. So to the left 5 and up 3, that should be quadrant 2. So these are gone. So quadrant 2, we're looking for left 5 and up 3, it's this one. Right there. Okay, let's take a look at number 17. Here we have to graph the cubed function. We know it's the parent function basically is centered, and it's an odd function, so it basically comes from up here, and then it comes around like that. Okay, so that's the parent function. And so we need to just shift this to the right 5 and up 7. To right here. So we're going to go up and curve it out. Okay? Alright, now we're going to switch it up and start actually writing the equation. Alright? So first of all, we see the parent function, that's x squared. And then if we look closer, this vertex is at the point, so it's 3 for x, and this right here is 1. Alright, so for something to move to the right, so we need, so y equals, this is x squared, so we have a horizontal shift of 3 and a vertical shift of 1. Okay, so this one has already been transformed. No shrinking or stretching is involved, so you don't have to worry about the a. But we do see that G is the blue one, and it got moved to the right 5 and down 2, which means that g of x must be side here, and negative 2. Number 20 says fill in each blank with the appropriate response. Remember that vertical stretch or shrink factor is positive. So the graph of y equals negative 5x squared can be obtained from the graph of x squared by vertically stretching or applying a factor of 5 that comes from here and reflecting across the x-axis okay. So let's take a look at number 21. As you can see here, there's a lot of things going on here. There's this, there's that, and there's that. There's 4 things that we need to cover. So let's go here. So the graph can be obtained from the graph by shifting horizontally 8 units to the left because it's positive, vertically stretching by a factor of 3, reflecting across the x-axis, and shifting vertically 9 units in the upward direction. Okay, fine. So now we're switching over to 2.6, which is composite functions, and we're going to find the domain of these functions. Okay, so remember the domain in a rational function, this cannot equal 0. So what x will make that 0, and that's obviously 6. So you add 6 to both sides, and you get x cannot equal 6. So if it cannot equal 6, that's the only place it cannot equal. It exists everywhere else. Okay, so we need to find the expression that talks about going up to the 6 and then having another part from the 6 to the other side, and that would be this one. Okay, so the visual of that would be something like an open circle, and you have the left side and the right side. Next, find the domain of the function. So the domain is going to exist everywhere that it can be 0 and it could be positive. So the inside of this has to be equal to 0 or greater than 0 or positive. So when we subtract 7 from both sides, we get negative 7. And because there's an equal sign, we're going to choose the bracket, and that's going to go to infinity to the right. Alright, next we have composite functions where we are going to do arithmetic. So we're going to add, subtract, multiply, and divide. So we have our 2 functions right here. And so for the first one, what is f plus g? 5x minus 5 plus g. So this is f, this is g. And we just simplify this to be 6x and negative 8. Okay. So that's f plus g. Okay, what's the domain? There are no restrictions in linear functions, so the domain is all real numbers. Okay. Next we have f minus g. Except you're subtracting a binomial. So we do have to distribute that. And we're going to get 4x minus 2. Okay, now what's the domain of it? This is linear. So once again, it's all real numbers. There's no restrictions. Okay, F times G. Okay, so here we just want to FOIL or distribute here. So 5x squared is the first arrow, second arrow, negative 15x, third arrow is negative 5x, and the last arrow is positive 15. Put these two together. Okay, and we know that this parent function is a quadratic, and there are no restrictions for the domain. So once again, all real numbers. Now we're going to do division. So we're going to put the F on top of the G. And that's basically it, and we're not going to divide that. But we do have a restriction in the domain. This, basically this can't equal to 0, and the x that's going to make that a 0 is going to be a 3. Okay, so this thing exists everywhere except for the 3, and that would be notated like this. The left side is negative infinity to 3, and the right side is from 3 to negative infinity, and those are both open circles, or open intervals. Okay, number 25, this is composite functions f of g and g of f, and the different scenarios there. Okay, so remember this is the inside out function or the egg function. So this right here is saying put G inside of F. Okay, G is the yolk, F is the shell. So F is just 9x. So that's my shell function, and then we're going to put G inside. G is x plus 9. So 9x plus 81. Okay. Now we're going to put G. Okay, so we have 36 plus 81. Will be 117. And if we put 4 inside of the F, which goes inside of the X, well, we have the equation already. It's 9x, plus 9. So 36 plus 9 is going to be 45. Okay, now, if we didn't have those equations, then we would go ahead and just put them in separately. So, for example, we put the 4 in here, and we get 36. And then we take the 36 and we plug it into the 9 separately. Okay, so that would be 45. Or we would put the 4 over here to start off with, and that would give us 13, and then the 13 we put into this one here. So just 13 times 9 is 117. Okay, number 26, we're going to determine whether these are inverses. And if you recall, inverses, the definition of that would be that if you put g inside of x, g inside of f, you're going to get just an x when you simplify, and same thing here. Okay, vice versa. So basically, do these two functions undo each other? And as you can see, we got the plus 6, the minus 6. Those two undo each other. And then we have the divide by 2 and the multiply by 2. So these definitely look like they're going to undo each other. Okay, based on our experience in our notes, in the homework, then this should be very familiar that this is going to be yes. Okay, so we're predicting that they both equal x and that they are inverses of each other. So here's the proof of that. If you just puts g inside of f, so g is our yolk, f is our shell. So let's do our shell, and let's put in our yolk. Okay, as you can see, the 2's cancel out, giving you x plus 6 minus 6, and those cancel out, giving you x. Okay, and vice versa. G is our shell function, and if we put f in here, you can see that those cancel out, and these cancel out, leaving you with x. Okay? So sometimes you don't have to necessarily show it. You can actually just kind of tell from that. But this is definitely proving it, is making yourself 100% sure without any doubt. Okay, so 27, we're going to find the inverse function. As you can see, this is 1 to 1. So if you remember, the first step is to know that it's 1 to 1. Okay, second step is to change the f of x to a y. Third step will be to change the x and the y, because the domain or range flip in inverse functions. And then we solve for this y right there. And divide by 4. So our final answer is y equals x minus 3 over 4. Okay, and as you can see, those will undo each other. Okay, the last step was just to rewrite the y as f inverse. Okay. Now, okay, I do want to go over another one. It's very similar to the one in our notes. Let me just go ahead and do the one in our notes. And it was f of x equals x to the third minus 1. So we make this y. We switch x and y. We solve for y. Take the cube root of both sides. So y is going to equal the cube root of x plus 1. Okay? Whoops. Okay. So, I want to just go over an extra problem to get you ready for the test. And that would be, okay, so I want to go over an extra example to get you ready for the test. So this one's a cubed function. So it's kind of in reverse. But let's see. So we switch this out. Just a second. Then we switch the x and the y. Then we start solving for y. So we want to get this guy by himself. So we need to do the cubed root in order to cancel out this cube here. So that will give us the y plus 5 by himself. And then we subtract 5 from both sides. And we replace this with our inverse function notation. Voila. Okay. Well, number 28, does a function have an inverse? We have the picture, so we're going to use the horizontal line test. As you can see, this passes. Okay, this does have an inverse. If it fails, then it does not have an inverse. Okay, we're going to do the horizontal line test again. And as you can see, this thing fails because it hits this horizontal line twice. So this does not have an inverse. Okay. This one passes. Okay. And that's it for 2.6. Now we're in the 2.7. Yeah, I meant 2.8. So this is 2.8. And we're going to do the distance formula. Okay, and I will provide you these formulas on the test. Okay, so let's subtract our x's. This came, by the way, this formula came from the Pythagorean theorem. So we have 12 squared minus 5 squared, 144, plus 25. Which equals 13. Okay, let's do midpoint. Gonna add up your x's like an average, and your y's like an average. do 8 plus 4. And 2 plus 10. So 12 over 2 is 6. And same thing over here. That's the midpoint between these two endpoints. Okay, so now we're going to our circle topics. And so our equation for the circle is, well, let's back up. Okay, x minus h squared plus y minus k squared equals r squared. So here we have our circle, h comma k, and we have our r, so we're going to put our h right here, k right here, and our r right there. So x minus 0 is x, so that's just x squared. Y minus 0 is y, that's y squared, and 4 squared would be 16. And that is it for writing an equation of a circle using the center and the radius. So let's take a look at our last couple questions here. And this time we have very similar things, but we have h and k. Okay, so don't forget about the negatives in the equation. So it's very helpful if you write the equation. And so the h is a negative 8, and the k is a 6. So notice that there's two negatives for the x part, so this is going to be positive 8. And this one's going to be negative 6 as usual. And we forgot our 10 right here, so that's going to be 100. The power 2. Okay. So this time we have an equation already, and we have to graph it. So we need to find out what the h is, what the k is, and what the r is. So if you look, h is going to be negative 1 because there's a positive in there. That means there must have been two negatives. This is a 4, and you need to do the square root of this, so that's going to be also 4. So the center is negative 1, 4, and the radius is 4. So we're going to graph this. So negative 1, 4 is about right there. And we need to go out from this as a radius of 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. And just connect the dots to the best of your ability. Okay, then the domain, as you can see, we have, that's a negative 5, and right here, that's a 3. So my domain is negative 5 to 3. And if you look at the range, it's down here, that's a 0, and up here that's an 8. So my range is going to be from 0 to 8. Okay, well that is it for Chapter 2, Part 2 unit or exam that we're going to be doing. So study, and let me know if you have any questions. All right, take care. See you in the next video.